Categories of standard Ethernet. Standard Ethernet common implementations 10 base 5, 10 base 2, 10 base T, 10 base F. For 10 base 5, bus thick coaxial, that is bus topology we are using. In 10 base 2, bus topology we are using, and it has a thin coaxial cable. 10 base T, star topology UTP cable, and 10 base F, star topology fiber optic cable. In 10 base 5 thick Ethernet, the first implementation is called 10 base 5 thick Ethernet or thicknet. The nickname that is derives from the size of the cable. 10 base 5 was the first Ethernet specification to use a bus topology with an external transceiver, that is transmitter and receiver, connected via a tap to a thick coaxial cable. This is a schematic diagram. This is a schematic diagram of a 10 base 5 implementation. 10 base 5 implementation. Cable length, cable length. This is transceiver. This is a thick coaxial cable, maximum length of 500 meter, and transceivable cable maximum 50 meter. So this is a digital band, baseband 500 meter, 10 megabits per second. And 10 base 2, this is a thin Ethernet. The second implementation is called 10 base 2 thin Ethernet or cheaper net. 10 base 2 also uses bus topology, but the cable is much thinner and more flexible. The cable that can be bent to pass very close to the stations. In this case, the transceiver is normally part of the network interface card, which is installed inside the station. The figure that shows the schematic diagram of a 10 base 2 implementation. This is the schematic diagram of a 10 base 2 implementation. And the cable end, this is a bend mark, and cable end, this is a thin coaxial cable which has a maximum length of 185 meter. 10 base 5, 10 base 2, 10 megabits per second, baseband digital 195 meters. 10 base T, twisted pair Ethernet. The third implementation is called 10 base T or twisted pair Ethernet. 10 base T uses a physical star topology. The stations are connected to a hub via two pairs of twisted pair cable, as shown in the figure. Note that two pairs of twisted cable that create two paths, one for sending and another one is for receiving, between the station and the hub. Here any collision happens in the hub. This is the 10 base T implementation. 10 base T hub, two pairs of UTP cable and twisted pair, baseband, and 10 megabits per second. And last one is the 10 base fiber Ethernet. Although there are several types of optical fiber, 10 megabits per second Ethernet, the most common is called 10 base F. The 10 base F uses a star topology to connect stations to a hub. The stations are connected to the hub using two fiber optic cables shown in the figure. This is the figure. 10 base F, 10 megabits per second, baseband digital fiber. This is the 10 base F hub, two fiber optic cables that are used here. This is a summary of standard Ethernet implementations. Media for 10 base 5 thick coaxial cable, 10 base 2 thin coaxial cable, 10 base T 2 UTP, 10 base F 2 by fiber. Maximum length 500 meter, here 195, here 100, here 2000 meter. Unline encoding Manchester, all ports are Manchester. Changes in the standard. The 10 megabits per second standard Ethernet has gone through several changes before moving to the higher data rates. These changes actually opened the road to the evaluation of the Ethernet. Bridged Ethernet. The first step in the Ethernet valuation was the division of a LAN by bridge. Bridges have two effects on the Ethernet LAN. They raise the bandwidth and they separate collision domains. In unbridged Ethernet network, the total capacity 10 megabits per second is shared among all stations with frame to send. The stations share the bandwidth of the network. If only one station has frames to send, it benefits from the total capacity. But if more than one station needs to use the network, the capacity is shared. A bridge divides the network into two or more networks. Bandwidth wise, each network is independent. For example, in figure 13.15, a network with 12 stations is divided into two networks, each with 6 stations. This is a diagrammatical representation without bridging, and this one is the with bridging. Another advantages of a bridge is the separation of collision domain. 13.6 figure 13.16 shows the collision domains for an unbridged and a bridged network. You can see that the collision domain becomes much smaller and the probability of a collision is reduced. This is a collision domains is an unbridged network and a bridged network. This one is the without bridging and this one is the with bridging. Here 4 domains we are using. Switched Ethernet. The idea of a bridged LAN that can be extended to a switched LAN. Instead of having 2 to 4 networks, why not have n networks, where n is the number of stations on the local area network. In other words, if we can have a multiple port switch, why not have n port switch? This is the switch Ethernet, which has the multiple number of domains. And full duplex Ethernet. One of the limitations of 10 base 5 and 10 base 2 is that communication is half duplex. A station can either send or receive, but may do not do both at the same time. The next step in the evaluation was to move from switched Ethernet to full duplex switched Ethernet. The full duplex more increases the capacity of the each domain from 10 to 20 megabits per second. Figure 13.18 that shows a switched Ethernet in full duplex mode. This is a full duplex switched Ethernet. And fast Ethernet. Fast Ethernet was designed to compete with LAN protocols such as FDDI or fiber channel. IEEE created fast Ethernet under the name 802.3U. Fast Ethernet is backward compatible with standard Ethernet, but it can transmit data 10 times faster at a rate of 100 megabits per second. This is the fast Ethernet topology. This one is the point to point and this one is the star topology. Fast Ethernet implementations. Common fast Ethernet implementations: 100 base TX. This is the 2 wires category 5 UTP, and this is the 100 base FX 2 wires fiber, and this one is the 100 base T4 4 wire category 3 UDP. This is an encoding for fast Ethernet implementation. Summary of fast Ethernet implementations. In media characteristics, it has a media number of wires, maximum length, block encoding, line encoding. In media 100 base TX, which has Cat5 UTP or STP. For 100 base FX, it has a fiber. For 100 base T4, it has a Cat4 UTP. In number of wires, for this one 2, and for 100 base T4 it uses 4 wires. And maximum length for this one 100 meter, this also 100 meter. In block encoding, which has 4B 5 by 5B, and 100 base FX for 4B/5B, and this one is nil. For line encoding, which has MLT3, NR is at 1 for 100, and 8B6 chip for 100 base D4. Gigabit Ethernet. The need for an even higher data rate resulted in the design of the Gigabit Ethernet protocol. The IEEE committee called the standard 802.3Z. In the full duplex mode of Gigabit Ethernet, there is no collision. The maximum length of the cable is determined by the signal attenuation in the cable. This is the topologies of Gigabit Ethernet. This is point to point, this is star, and this one is 2 stars, and last one is the hierarchy of stars. Gigabit Ethernet implementations. In Gigabit Ethernet implementations, 1000 base SX 2 wire shortwave fiber and 1000 base LX 2 wire long wave fiber, 1000 base CX 2 wire copper STP, and 1000 base T 4 wire UTP. Encoding the gigabit Ethernet implementation. This is the diagrammatic schematical expression of the encoding in gigabit Ethernet implementation diagram. Summary of gigabit Ethernet implementation. Characteristics: media, number of wires, maximum length, block encoding, line encoding. For this 1000 base ASX fiber shortwave to 550M 8B by slash 10B NRZ, and for this one fiber long wave to 5000 meter 8B 10B NRZ. For 1000 base CX STP to 25M 8B 10B NRZ. For 1000 base T Cat 5 UTP 400M 4D PAMP 5.